Hello everyone and welcome back to our channel. In today's video, we're going to explore one of the most fundamental aggregation functions in PySpark, the sum function. Whether you're working with financial data, sales records, or any other numeric dataset, knowing how to effectively sum values is crucial for drawing meaningful insights. I will show you how to use the sum function to calculate totals, perform group sums, and get a comprehensive overview of your data. So let's dive right in and simplify summing values with PySpark. Introduction to the sum function. The sum function in PySpark is used to calculate the sum of numeric values across one or more columns. This function works similarly to the sum function in SQL and is one of the most commonly used aggregation operations when working with data. By adding up the values within a specified column, sum helps you quickly determine important metrics such as total sales, total revenue, or total quantity sold. This makes it especially useful in domains like finance, sales, and inventory management, where deriving the total of a numeric value provides critical insights. The sum function can be applied directly to a column or used in combination with functions like group B to calculate the sum for different groups of data. For example, if you have a dataset that records sales transactions, you might want to use sum to calculate the total sales across all items or within specific categories. This helps to derive meaningful insights such as understanding the total revenue generated from each product, store, or region. Another important aspect of the sum function is its efficiency in dealing with large scale datasets. PySpark is built to handle distributed data processing, meaning the sum function can calculate the total value for millions or even billions of records efficiently. By using sum as part of the aggregation process, data engineers and analysts can easily summarize their data, identify trends, and generate reports that highlight key metrics in a dataset. Whether working with financial data, transactional records, or inventory numbers, the sum function is a foundational tool that helps transform raw data into actionable information. Basic syntax. The basic syntax for using the sum function in PySpark involves combining it with group by to aggregate numeric values across a data frame. Specifically, the syntax is dataframe.groupby calls.ag sum column name. Here, the group by part is used to specify one or more columns that you want to group the data by, and the add function is used to apply the aggregation operation to each group. The sum column name part of the syntax applies the summing operation to a specific column, calculating the total value for that column within each group. The calls parameter allows you to specify which columns you want to use to create groups. For example, if you have a sales dataset with columns for region and sales underscore amount, you might group by region to calculate the total sales for each region. This allows you to break down the overall data into smaller segments, making it easier to analyze specific groups separately and understand how each group contributes to the total list. The sum column name function is applied to a specified column within each group to compute the sum of all values for that column. For example, if you are grouping by region, you could use sum sales underscore amount to calculate the total sales for each region. This helps you understand metrics like the total sales volume for different categories, regions, or time periods, depending on how you choose to group the data. The aggregation is performed for each group individually, and the result is a new data frame that contains the grouped values along with the aggregated sum for the specified column. Overall, the combination of group by and sum is a powerful way to derive summary statistics from a dataset. It allows you to break down your data into specific categories and calculate totals for each category, helping to reveal important insights about trends, contributions, and bit distributions within data. This syntax is particularly useful for creating detailed reports, understanding sales or revenue by different dimensions, and conducting other forms of data analysis that require grouping and aggregate values efficiently. Why use sum? The sum function is an essential tool for computing total values in data analysis, making it ideal for aggregating metrics such as sales, profit, expenses, or any other numeric stuff. In the world of data analytics, calculating totals helps derive key insights from the raw numbers. Whether you are calculating total revenue for a business, adding up total expenses for a project, or analyzing the total production output of a factory, the sum function makes this process straightforward and efficient. It provides a comprehensive view of the accumulated values in a dataset, making it an invaluable tool for decision making and reporting. One of the strengths of the sum function is its versatility in being used either globally or in combination with group by. When applied globally across the entire data frame, sum gives a complete overview by calculating the total of a specific column, such as total sales or total cost, across all records. This helps understand the overall magnitude of a metric, giving a holistic picture of the data at hand. On the other hand, sum can be used in combination with group by to calculate group decimes. This allows you to break down the total into meaningful categories. For example, you could group by a column like region, product underscore category, or month, and then apply sum to calculate the total value for each group. Grouped sums are useful for comparing different segments of your data, such as comparing sales between regions or calculating the monthly revenue. This level of analysis helps identify trends, track performance across different groups, and make more informed business decisions. Overall, the sum function is fundamental in data aggregation, allowing you to transform raw numeric data into insightful metrics. Whether used for global totals or group sums, it is one of the most important tools in data analysis that helps transform data into actionable information, providing the foundation for understanding and summarizing the dataset effectively. Practical examples: 1. Summing a single column. In this example, we are working with a PySpark data frame diff that contains sales data for different items. The data frame has two columns, item and salaries, where item represents the name of each product and sales represents as the corresponding sales value. The dataset includes multiple records for different items, some of which appear multiple times with different sales values, representing individual sales transactions for each item. Goal here is to calculate the total sales across all items in the data frame. To achieve this, we use the add function in combination with the sum function. The sum sales part calculates the sum of all values in the sales hash column, effectively giving us the total sales for items in the dataset. This is a global aggregation, meaning that the sum is computed across the entire data frame rather than being broken down by specific groups. To make the result more understandable, we use alias total underscore sales to rename the aggregated column to total underscore. This helps in clearly identifying the output, indicating that the value represents the total sales amount. The resulting data frame will contain a single row and a single column named total underscore sales, showing the sum of all sales values from the original data frame. Finally, we use the .show method to display the result. The output will provide the total sales amount for all items in the dataset, making it easy to understand the overall magnitude of sales. For example, if the sales values are 100, 200, 300, 400, and 500, the sum will yield a total sales value of 1500. This example demonstrates how you can use egg along with sum to perform a global aggregation and compute a sum of a specific column. Calculating total sales or any other numeric metric is a fundamental operation in data analysis, providing an overview of the entire dataset and helping to answer high-level business questions such as total revenue or total expenses. The use of alias ensures that the output is clearly labeled, making it more informative and easier to interpret for further analysis or reporting. 2. Grouping and summing values. In this example, we are working with a PySpark data frame that contains sales data for different items. The data frame has two columns, item and sales, where item represents the name of each product and sales represents the sales value for that item. This dataset may have multiple records for the same item, reflecting different sale and pick actions for the same product. The goal here is to calculate the total sales for each individual item, which involves grouping the data by the item column and then summing up the sales for each group. To accomplish this, we first use the group by function specifying the item column. This groups the rows of the diaphragm by the unique values in the item column, effectively grouping together all sales records that belong to the same item. Once the data is grouped, we use the add function along with sum sales to calculate the total sales for each group. The sum sales operation adds up all the sales values within each group, giving us the total sales amount for each item. For example, if item A appears multiple times in the dataset with sales values of 100 and 300, the sum will result in a total sales value of 400 for item A. To make the output more readable, we use alias total underscore sales to rename the resulting column as total underscore sales, indicating that it represents the total sales for each item. Finally, we use the dot show method to design data frame. The output will have two columns, item and TL underscore sales, where item lists each unique term in the dataset. On total underscore sales, the story exclusion of dollars for the item. His example illustrates how you can use group by in combination with agg and sum to calculate sales for equal item. Group aggregation like this is particularly useful for understanding the sales performance of individual products, as it allows you to see how much revenue each item contributes to the overall dataset. This approach is beneficial for analyzing trends, comparing performance across different products, and making the data-driven business decisions such as identifying top-selling items or even specific sales performance. 3. Summing multiple columns. In this example, we are working with a PySpark data frame data underscore multi that contains sales and profit data for different items. The data frame has three columns: item, sales, and profit, where item represents the name of each product, sales represents the corresponding sales value, and profit represents the profit associated with each item. The dataset contains multi-codes for the same item, representing different sales transactions and their respective profits. The goal here is to calculate the total sales and total profit across the entire data frame, which means we want to sum up all the values in both the sales and profit columns. This type of aggregation gives us a global summary of the dataset, providing insight into the overall revenue and profit generated by all items combined. To achieve this, we use the aggregate function to perform multiple aggregations simultaneously. Specifically, we apply some sales to calculate the total of all values in the sales column and some profit to calculate the total of all values in the profit column. By using alias, we rename these aggregate columns as total underscore sales and total underscore profit to clearly indicate the meaning of the values in the output. This makes it easy to interpret the resulting data frame, which will show the overall sales and profit for the entire dataset. The dot show method is then used to display the resulting data frame, which contains two columns, total underscore sales and total underscore profit. The total underscore sales column shows the sum of all sales values from the data frame, while the total underscore profit column shows the sum of all profit values. For example, if the sales values are 100, 200, 300, 400, and 500, and the profit values are 10, 20, 30, 40, and 50, the resulting total underscore sales will be 1500 and total underscore profit will be 150. This example demonstrates how you can use ACT along with sum to calculate multiple global metrics across a data frame. By calculating the total sales and total profit, you get a complete picture of the overall performance of all items in the dataset. This type of analysis is particularly useful for generating summary reports understanding the scale of your business metrics, and providing high level insights that can guide strategic decision making. 4. Summing with a conditional expression. In this example, we are working with a PySpark data frame that contains sales data for various items. The data frame has two columns, item and sales, where item represents the name of each product and sales represents the corresponding sales value. The dataset includes multiple records, each reflecting the sales for a specific item. Our goal here is to calculate the total sales, but only for those sales values that exceed a specific threshold, which in this case is 200. To achieve this, we use the when function from PySpark in combination with the sum function. The when function helps to create a conditional expression that allows us to include only the sales values that meet a certain condition. Specifically, when df.sales200 df.sales checks each row in the sales column, and if the sales value is greater than 200, it returns that value, otherwise it returns null. Essentially, this condition allows us to selectively filter the values in the sales column so that only sales greater than 200 are considered for aggregation. Once the conditional filtering is set up using the when function, we use sum to calculate the total of the filtered sales values. The sum function is applied to the output of the when function, meaning only the sales values greater than 200 are added together. We then use alias total underscore sales underscore over underscore 200 to rename the resulting column as total underscore sales underscore over underscore 200 shy, which clearly indicates that the value represents the sum of sales greater than 200. Finally, we use the dot show method to display the result. The output will contain a single column, total underscore sales underscore over underscore 200, showing the sum of all sales values that are greater than 200. For instance, if the sales values in the dataset are 100, 200, 300, 400, and 500, the when condition will include only 300, 400, and 500, resulting in a total sales value of 1200 for those records. This example demonstrates how you can use conditional logic in combination with the sum function to perform selective aggregation in PySpark. By using when to filter the data before applying sum, you can calculate weighted metrics based on specific criteria, providing deeper insights into your data. This approach is particularly useful when you want to analyze data that meets certain conditions, such as calculating total sales above a certain threshold or understanding the contribution of high value transactions to the overall dataset. 5. Summing without grouping global aggregation. In this example, we are working with a PySpark data frame deep that contains sales data for various items. The data frame has two columns, item and sales, where item represents the name of each product and sales represents then the corresponding sales value. Each row in the data frame represents a different sales transaction for a particular item. The goal here is to calculate the total sum of all sales across the entire data set without breaking the data down by groups or categories. To accomplish this, we use the add function in combination with sum sales. The sum sales operation computes the total value of the sales column for all rows in the data frame. Since this is global aggregation, it sums up the sales for all items collectively, giving us the total sales for the entire data set. This global sum provides a high-level view of the total sales generated from all transactions recorded in the data frame. We use alias total underscore global underscore sales to rename the resulting column as total underscore global underscore sales, which helps make the output clear and easy to interpret. The new column name explicitly states that the value represents the total sales across the entire dataset. Finally, we use the dot show method to display the result, which consists of a single row with one column named total underscore global underscore sales. The output of this operation provides a summary metric that is useful for understanding the overall performance of the sales recorded in the dataset. For instance, if the sales values are 100, 200, 300, 400, and 500, the sum function will compute the total as 1500. This global sum gives you a straightforward answer to how much revenue was generated by all items combined, providing a comprehensive overview of your dataset's total sales. This example demonstrates the usefulness of using ag-along-sum for computing global aggregations. Calculating the total sales without grouping is often a fundamental step in data analysis, allowing you to get an initial understanding of the dataset's magnitude. It is especially helpful in financial or sales analysis, where the overall revenue or cost needs to be determined as a first step in the decision-making process. 6. Summing multiple aggregations in AG. In this example, we are working with a PySpark data frame diff that contains sales data for different items. Data frame has two columns, item and sales, where item represents the name of each product and sales represents the sales value for that product. Some items appear multiple times in the dataset, indicating that multiple transactions have been recorded for the same item. The goal here is to analyze the data by calculating the total sales for each item and also counting the number of transactions for each item. To achieve this, we first use a group by function to group all the rows by the unique values in the item column. This step groups together all transactions that correspond to the same item, allowing us to perform aggregate calculations for each item. After grouping the data by item, we use the ag function to apply multiple aggregation operations. First, we use sum sales to calculate the total sales for each item. This gives us the sum of all sales values for each group, providing insight into the revenue generated by each product. We use alias total underscore sales to rename the resulting column and as total underscore sales to clearly indicate that this column represents the total sales amount for each item. Next, we use the count function to count the total number of transactions for each item. The count operation counts all rows within each group, effectively giving us the number of times each item appears in the dataset. This count helps in understanding how frequently items are sold, providing additional insight into sales patterns for each product. We use alias total underscore transactions to rename the resulting column, making it clear that the value represents the number of transactions for each item. Finally, we use the dot show method to display the resulting data frame. The output contains three columns: item, total underscore sales, and total underscore transactions. The item column lists each unique product. Total underscore sales provides the sum of sales for each item, and total underscore transactions shows the count of transactions recorded for each item. For example, if item A has two transactions with sales values of 100 and 300, the total underscore sales for item will be 400 and total underscore transactions will be 2. This example illustrates how you can use group by along with add to perform multiple aggregations for each group. By calculating both the total sales and the number of transactions for each item, you can gain a more comprehensive understanding of the sales performance for each product. This approach is useful for identifying which items are generating the most revenue and how frequently they are being sold, which can help in making data-driven decisions related to inventory management, pricing, and sales strategy. Thank you so much for joining me today as we explored the sum function in PySpark. I hope you now have a solid understanding of how to use this function to calculate totals and perform group sums in your datasets. Summing values is at the core of data analysis, and mastering this function will help you better understand your data and make data-driven decisions. If you enjoyed this video, please give it a thumbs up. share it with others, and don't forget to subscribe for more data analytics tutorials. If you have any questions or suggestions for future videos, feel free to drop them in the comments below. Until next time, happy coding and keep exploring the power of PySpark.